study for. All right. 1-1, graphing.
Where you at? 1-1?
Yeah. From this moment on, you are going to be doing a lot of graphs. We'll start off with just plotting points. Then we'll work into lines. Then we work into parabolas. Then we work into transforming the graphs. You are going to be sick of graphs, but you need to know how to do them. And they're really not that hard. Usually a graph on a test question should be the simplest one. It should be the easiest out of all of them.
But I'm not going to do graphing in my work. Do I have to learn it?
I don't care. You're not going to do any of this stuff on your job.
Yeah, I know.
All
I
is for. Well, I mean, what's the whole reason of learning math? Why was it taught all these years from Greeks on?
To get us extra wrinkles in our brain?
That too.
I think
And that's basically the whole idea, because math started off as a philosophy, and
think
philosophy is
brain thing.
training your brain how to think. So guess what kind of job you're going to get if your brain actually works?
A very high.
Good ones.
A good
What kind of
high
job do you get
job.
if your brain don't work?
A good
Not so good one.
Plastic.
What'd she say?
Would you like fries with that?
Yeah. That kind of job.
Paper and plastic.
And then even I worry about those people. Did you order fries?
Yep.
Yeah. Oh well.
Here you go.
So graphing. Let's start off with, we have a number line. 0 separates, the positive side from the negative side. And we're going to call this one the x-axis. Awesome. Really boring, right? To get into graphing, though, we want to plot ourselves in a plane. We're going to run another axis on it. It's technically just another number line. We're used to number lines going horizontally, but number lines also go vertically. Think of thermometers, the old mercury
Glass
thermometers, the glass ones. Those are a y-axis, they run up and down. Altitude, is a y-axis going up and down. But most people think horizontally because we're very, two-dimensional creatures. We walk on a surface. We don't really fly around like birds do. Okay. And on the y-axis, this is also 0, so this point becomes really important, the intersection of the horizontal and vertical number lines. Anybody know what the name of it is? Origin. It's specifically called origin because that's where you start. Whenever you're plotting a point, you have to go to the origin and move from that position. The x-axis is going to, I'm going to say this a million times, and it's amazing how many people go the wrong direction. The x-axis only does one thing. It goes left and it goes right. The y-axis only does one thing. It goes down and it goes up. It cannot go diagonal. There is no such thing as diagonal motion until you're on a line or something like that. All right, and then down, of course, is negative and up is positive. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Best way to remember that is to draw a C. Quadrant 1, 2, 3, 4, in that order. So you're moving in this direction, counterclockwise. All right, so when you're plotting a point, most people know how to do this. If you're going to plot, -3, 4, where do you go?
You go negative 3.
You go -3 to the left,
And you go up.
and you go up 4, which would be here. Yay. Most people are good at that. And it's funny how people's brains go. Like mine, when I plot -3, 4, for some reason I go 3 to the left and 4 down, because my brain is just weird. It's dyslexic, so it throws things off. So if I plot a point wrong, it's usually this type of point. What do most people plot wrong?
The X. They put it on the Y.
Yeah. If you're over here at this coordinate, what is the name of that coordinate?
It is on the
X.
I know, it's an x-intercept. We'll give it that. This is called x-intercept.
It's 4-0.
And then people get confused between 4, 0 and 0, 4.
It's 0-4.
Now you got to remember, every coordinate is an x and a
Y.
y. X goes left and right, y goes up and down. So we went to the right 4 units and didn't go up and down, so that has to be 4, 0. But it's funny that people will plot y-intercepts as x-intercepts and x-intercepts as y. Be really careful of these two. If I go down 5 and I plot this point,
It's 0, 5.
this is a y-intercept. and it's 0, -5 because we went down 5, but we did not move left or right. Those two are extremely important. X-intercepts and Y-intercepts you're going to get sick of. Okay. The important thing about X-intercepts and Y-intercepts are this. If you're dealing with an X-intercept, the only thing that is true when you are an X-intercept, anywhere on the X-axis, what's the only thing that stays constant? What's equal to 0? The Y is equal to 0. The Y is equal to 0. So if you are an X-intercept of any graph, your Y coordinate has to be 0. If you are a Y-intercept of any graph, then your X coordinate has to be 0. Has to be, without a doubt. So those are two really major things that we're going to be working with the entire semester. The rest of it. Right, so I'll be asking, how do you find an X-intercept? And you have to tell me that Y has to be equal to 0 and so forth and so on. So, for instance, we have a simple little equation, x plus 4y equals 16. If I want to find the X-intercept, I know that I need to have y is equal to 0. So all I have to do is take this entire equation, substitute y equals 0, and solve for x. So this becomes x plus 4 times 0 is equal to 16. 4 times 0?
0.
0 multiplication property. 0 plus x?
0.
Additive identity property. And you get x equals?
16.
Don't I love just saying properties?
You plug in.
Okay, simple version. You plug in 0 for y, the y's cancel out the term, and you're left with x equals 16. So, now here's the problem. I have y equals 0 at the top and x equals 16 at the bottom. If we're talking about coordinate math, you have to label everything as an x and a y as a coordinate, or what's called an ordered pair. Ordered pair. So what's the ordered pair for the X-intercept?
0.
Is it 0, 16 or 16, 0?
16, 0.
16, 0. Now, if I want to find a Y-intercept, I just have to turn around and
Plug in 0 for x.
let x equal 0. So we're going to get 0 plus the 4y is equal to 16. 0 plus 4y, of course, is
4y.
additive identity. And then we're going to get y is equal to
4.
divide both sides by 4. Now this is also a coordinate, and the coordinate is, well,
0 by 4.
x is equal to 0 and y is equal to 4. Here's a clue for this entire chapter. If I tell you what x is equal to, you need to find y. If I tell you what y is equal to, you need to find x. You will never just have one value. You're always going to be working with 2 for most of this rest of the book. So be really careful of that when we're talking about coordinates. All right. Let's graph something. Yeah, for the fun of it. We got time. Oops. Gotta get back into practice. Let's see, we're going to graph y equals 3 minus x plus 2 all squared. Now later I'm going to teach you a technique, well, much later in the semester, I'm going to teach you a technique how to sketch the graph of this. But this one I want to physically graph it. There's a difference between sketching and graphing. Graphing is very specific position. Sketching is kind of just a shape. So the technique that we're going to use will work for any graph. If you want to graph something, this technique is guaranteed to work, and it's what graphing calculators do anyways. So we're going to set up a table. We're going to choose some x values. We're going to choose some, or generate y values. We could do the opposite. It's just this is normal this way for a specific reason. And in the middle, we're going to plug these x values into that position. right here. Okay. Now, what x values do I choose?
Whatever you.
Any ones that I want. Now, on a test, I'll tell you specifically which ones to choose because I don't want you plotting -2, 48. That just doesn't help us any. So let's see.
-1.
I always do 0, or -1, 0.
Always start with negatives. Well, I'll tell you which word to start because that's pointless to go all over the place. So we'll start at -4. So this becomes 3 minus parentheses. What's -4 plus 2?
It's -2.
-2, and we're going to square
It's 4.
it. Right. And the final answer is?
-4.
Well, this is 4.
-1.
3 minus 4 is?
-1.
-1. Alright. And then once you choose a start point and you find a point that comes out nice, just keep going in order.
3 minus.
This is -2 squared, which is +4. 3 minus 4 is -1. Don't get confused with this minus and that square. That doesn't change that minus. Alright, -3. 3 minus, well, -3 plus 2.
It's -1.
-1 squared,
It's
3 minus 1
2.
is 2. -2. 3 minus, -2 plus 2.
0.
0 squared.
0.
And then 3 minus 0, of course, is
3.
3. -1. And we're going to just keep on going until things don't work anymore. -1 plus 2.
It's 1.
-1, I'm sorry, 1 squared.
1.
1. 3 minus 1.
2.
2. 0. 3 minus,
How many points do you need
until it stops working.
until it stops working?
Until it goes off of graph paper. Usually anything bigger than 10 or smaller than -10. Notice these are nice numbers so far.
Yeah,
so
yeah, so
let's keep
far.
on going. Plug in 0. 0 plus 2.
2.
Please don't say 0. 2 squared.
4.
4. And you get 3 minus 4, which is?
-1.
Hey, look, we're back to -1. Isn't that weird? 1.
1 plus 2 is 2.
1 plus 2 is 3. 3 squared is?
9.
3 minus 9 is?
-6.
2.
It's 4. 4 squared is 8. 16.
Willie's going to get hit. 8 is 16. And 3 minus 16 is?
-2.
That one's off. So I'm going to stop there. Alright, and then we just plot this thing.
It's a parabola.
1, 2, 3, 4, 5, 6.
It is a problem because it's squared.
3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Graphing is fun. Get nice pictures out of it. Alright, let's plot some points. Now, these are all x, y coordinates. So this is the coordinate -4, -1. I'll write the first one. And you plot a point exactly at that location. Don't move it anywhere else. So it's -4 to the left and down 1. So it's right here. So it starts off there. The next point is -3, 2. So -3 up to here.
-2, 3.
-2, +3 here.
-1, 2.
-1, +2.
0, 1.
0, -1, which is here. What is this one called?
It's called the
Y intercept. It's on the y-axis, but it's called a y-intercept. All right, and then where were we? 0.
-6.
1, -6, which is way down here, and we get a graph that looks like that. Now, here's a problem. You were taught to connect the dots ever since like 3rd, 2nd, kindergarten, someplace way back then. You were taught to connect the dots and you get pretty pictures. The problem with that, with graphing, and we have to advance your knowledge a little bit. If I have 2 points on a graph, how many different ways are there to connect them?
Infinite.
Infinite number of ways. And some of them are nice and some of them are not so nice. I mean, there is a possibility that the 2 points don't even connect. There are graphs that look like this. I can have a point here and a point here. This graph goes off this way. This graph goes off this way. And those points never ever connect with any line segment. There is also the possibility that your graph does this. Goes crazy in between the 2 points. So we're going to, take away a few ideas. This is called a discontinuous graph. We're not going to work with them until chapter 3. This is called a non-smooth graph. We are never going to work with these. These are usually calculus and above that play around with these ideas that graphs fluctuate a lot. So when we're talking about graphs, we're talking about continuous. That means you never take your pencil off the piece of paper when you're drawing it. And smooth, very smooth. We're not going to have graphs that have points like this. This is called a cusp. It's an instantaneous change in direction, which is totally impossible in the real world. And we're not going to have this is just called crazy. But there are graphs that go crazy. I can come up with a few right off the top of my head. So since this is smooth and continuous, we're going to draw our graph through it. It's going to look something like this. Now, I'm not sure about the arrows, but we'll deal with those later. The other thing that's interesting is the points kind of stay in a pattern right after another all the way up to, between the 2 points. There's, not a jump up here and then it comes back down. So when we talk about smooth, we're talking about from one point to another, we're just going to get a nice curve. To get into why that actually works, you really do have to take calculus. Why there are points, an infinite number of them, that lie on a nice smooth curve rather than jumping all over the place. So there's our graph. Isn't that pretty?